Let's learn chapter exponents and radicals. What do you mean by exponent? Is a small number written above a base number to show how many times base is multiplied. Just general, the number above a base is exponent. You see this 3 is an exponent, 2 is an exponent. That's what do you mean by radical? Radical is used to find root of a number and it is opposite to exponent. Like you see here, there is a radical along with number. We can turn that into exponent. When you turn that into exponent, the root turns to denominator of the here you see cube root turning to the denominator of the exponent. In the same way, square root of 9. Then when you change this root to exponent, it turns to 9 raised to 1 by 2. Just this value turns into denominator of the exponent. If it is 10th root of 100, then it's going to be 101 by 10. So just this radical turns into denominator of the exponent. Let's learn some basic exponent terminology. In ax to the power of n exponential expression, you already know that n represents exponent and x represents base. Thing which is in front of base is coefficient. So for this example, 3x power 4, coefficient is 3. That is the numerical factor in front of the base x, and x is the base. In the same example, 3x power 4, base is the number or variable that is repeatedly multiplied by itself based on exponent. The same example, 3x power 4, exponent is 4, meaning x is multiplied 4 times. 1 time, 2 time, 3 time, 4 times. If the exponential form is 4 to the power of 5, then 4 is multiplied by itself 5 times. So it depends on the exponents, how many times the base need to get multiplied. How to read exponents? So this is read as x squared, this one as x cubed, and here if there is a variable at exponent place, read it as x to the power of n, and this one as 5 cubed. Let's learn some exponent rules along with examples. So first one, exponent product rule. When multiplying exponential expressions with same base exponents, so that turns to x raised to plus n. When multiplying exponential expression with the same base, here you can see base is 2 for both exponential expression, then exponents. That's the rule. Or if you do in this way, 2 raised to 3, 2 raised to 4, that will be 2 into 2 into 2, 2 into 2 into 2 into 2. So 2 raised to 3, 2 raised to 4. So it's all together, if you count 1, 2, 3, 4, 5, 6, 7. 2 raised to 7. If you multiply all these 2's, you get a result which is going to match with the result of this one which you used product rule. So instead of going with longer version, just try to add exponents and get the answer quick. When raising a product to an exponent, distribute the exponent to each factor in the product. So here we are distributing this exponent to each factor in the product. So that will be 3 square 4. It's a basic. Let's see what's this exponent quotient rule now. When you're dividing exponential expressions with the same base, again you can see clearly the base is x in numerator, base is x in denominator of exponential expressions. If that is the scenario, just subtract the exponents. So you can see here example 5 raised to 6, 5 raised to 2, where base is common in both. You can use this rule and just subtract the exponent to get the result quicker. Or if you go with general way, you still get solution, but it's bit lengthy. So 5 to the power of 6, which will be 5, is multiplied by itself 6 times, and here it's multiplied by itself 2 times. So if we cross out 1 5 and another 5 in the numerator and denominator, same again, so we end up with 5 power 4. So this way, or you can follow this way, but moving with quotient rule, x raised to the power of minus n, which is easier and quicker. And here there is another rule. When you are raising a fraction to an exponent, distribute this exponent to both numerator as well as denominator. Just like the previous one, you just have to distribute the exponent of the product which is inside for the previous one. Now it is same for inside, you have to distribute for both numerator and denominator. That's now here there are two more rules: exponent power rule, negative exponent. So in this exponent power rule, when raising power to another power, you see here for this exponential expression, there is already power. We are raising that to another power. You just have to multiply both exponent. That's it. It leads to a quicker result. You see here example 3 raised to 2 whole power 3. So just multiply the exponents, you get the actual traditional way is 3 raised to 2 is raised to 3, that equals to 3 raised to 2 multiplied by its 3. So here you can apply the product rule. Base is same, so you can just add the exponent 2 plus 2 plus 2, that's 3 raised to 6, which is same comparing with this. So you can go with traditional way or you can just follow this method, power rule, to get quicker solution. Coming to fourth rule, negative exponent rule. Here you can see x raised to the power of negative. Here the negative exponent represents reciprocal of the base. You can see it's just reciprocal of the base. It's just turning negative exponent to positive exponent. You see here 3 raised to negative 4, we are turning it to reciprocal of 3 power 4, where this negative exponent turned to positive exponent. Same way for 5 power negative 2. If you want to turn this negative exponent to positive exponent, just reciprocate, it will become power 2. That's it. Here are the all laws of exponents. You already know that x power 1 is x. You can see the example. Anything to the power of 0 is 1. That's a basic law. And we already gone through all these: product rule, quotient rule, power rule, and negative exponent rule. These are at one place. You can go through this. And here there is one more thing: bases are equal, then exponents must also be equal. Like if a power that equals to a power n, here bases are equal, then their exponents also equal. Let's say 5 power that equals to 5 power 2, bases are equal, then value equals to 2, exponents also equal. Let's see the difference between negative 3 whole square and negative 3 square. So according to the PEDMAS, we are going to give first priority for the parenthesis in negative 3 whole square. So here exponent is 2, so base inside the parenthesis is going to get multiplied by itself twice, 2 times, because of the exponent 2. So negative 3 in parenthesis times negative 3 in parenthesis, that's going to be negative into negative, that's going to be positive. 3 into 3 9, so it's positive 9. Now in negative 3 square, we are going to give first priority to exponent, not the negative thing. So negative we just keep as it is and we multiply 3 with itself because of the exponent 2 for this base 3, and then we multiply 3 into 3, which is 9, and then we give this negative sign to the 9. It's going to be negative 9. So both are not same. Because of this parenthesis and without parenthesis, the value is going to change. So be careful with this. And sometimes here if it is 2 and here also 2 inside the parenthesis and exponent is 3, but here the answer is same, negative 8 only. How come? If you solve this, negative 2 whole cube, that's going to be negative 2 in parenthesis, negative 2 and negative 2, because the exponent is 3. So 2 2 2, which is going to be 8. 2 times 2 times 2, which is 8, and negative into negative positive, and positive in and this negative, that's going to be negative. So the answer is negative 8. If you solve this one, here you have to give priority to exponent first, not the negative. So just keep that negative as it is and then try and multiply 2 times 2 times 2. So that's going to be 8, and then you give this negative sign to 8. It's going to be negative 8. Here in this situation, both are same scenarios, but answer is different. So be careful. To avoid this confusion, I'll tell you one thing. Whenever the exponent is odd, then the output is negative. Whenever the exponent is even, then the output is positive. You see, in all these three examples, I took negative 2 inside the bracket, I mean in parenthesis. Here also three examples with even exponents, 2, 4 and 6. And here I took all are odd exponents. On solving these odd exponents, I ended up with negative 8. Whenever it is 5 as odd exponent, I ended up with negative 32. And odd exponent 7, I ended up with negative 128. So what you noticed, whenever it is odd exponent, you are going to get negative output as your result. In the same way, whenever it is positive exponent, then the result is going to end up with positive. So just remember in that way. Example number 1. Which of the following is equivalent to negative x square parenthesis negative x whole power 5? So we have option A, B, C, D. Negative x square parenthesis negative x whole power 5. So just now we learned something about part negative x whole power 5. Here you can see, if it is odd exponent, we end up with negative output. You can just go through this once. Just now we did, if the base inside is with negative and it has a odd exponent, then it's going to end up with negative. If the base inside the parenthesis is negative and its exponent is positive, then you end up with a positive result. So it's just like positive into negative is positive, and then this positive and this negative is going to give you a negative. Here positive into positive, sorry, negative into negative is positive. The same way, if you go with this two and this two, you end up with positive positive, so it's finally positive. So that's it's going to work. So here in this case, it's negative x whole power 5. Clearly the exponent is 5 and the inside the parenthesis the base has a negative number, I mean sorry, negative sign. So that's going to be negative x power 5. If you want to expand and solve, negative x whole power 5. So negative x, negative x, negative x, negative x, and negative x. So negative into negative, it's positive. Negative into negative, positive. One negative. Positive into positive, it's positive. And here this one negative. This positive and this negative end up with negative. So 1, 2, 3, 4, 5. So you end up with a negative x power 5. I just kept this negative here. So instead of doing all that, the technique to write it directly. So we are with negative x square times negative x power 5. So we learned something from product rule. X power times x power n, that equals to x power plus n. So this is what we know from the product rule. That's going to be here negative into negative, it's going to be positive, and apply the product rule. X power 2 plus 5, that's going to be positive x power 7. Example 2. Which expression is equivalent to 4 power x plus 1 times 3 power 2x, where x value is greater than 0? So for the given expression, one among this option A, B, C, D is going to be equal. So which one is that? So the given 4 power x plus 1 times 3 power 2x. Here I'll apply product rule. 4 power x and 4 power 1. X power plus n, that's equals to x power times x power n. That's what I applied there. And here for the second case, I mean the second one, it is in the form of 3 power 2x. So I just separate it, 3 power 2 and x. It is in the power rule. X power whole power n, that's going to be x power n. So actually it is in x power mn. I wrote it like x power whole power n. I wrote it this way. So now it's 4 power x, 4, and 3 square is 9 and power x. So you can see here 4 power x and 9 power x, it has exponent or power same. So that's, I'm going to write as this 4, and in bracket 4 and 9, and its common power x. So that's going to be 4 times 9, which is 36, whole power x. So you can see that's option C. Let's learn the relation between roots and exponents. You see, roots are opposite of exponent. Roots or radicals. I'm talking about roots or radicals which are opposite of exponents. You can see 5 square is 25. Root 25 is 1. But how? So we can turn 25 as 5 square, and you can directly cross out this. But how actually root and the exponent is getting crossed out? So actually radical, we can write it as exponent, which is 1 by 2. Whatever the number is there with the radical, that turns to this. Here 3 is there. So cubed root is there, it turns to 1 by 3. The root becomes the denominator of the exponent. The root becomes the denominator of the exponent. The same way here, square root, for square root we don't mention 2, so this root becomes the denominator of the exponent. So on multiplying this 2 by applying the power rule, 2 into 1 by 2 will be 2 by 2, so crossing out 2 and 2, you end up with 5. So same way here, cubed root of 6 cube, so this root turns into denominator of the exponent. And applying the power rule, 3 times whole power 1 by 3, so 3 times 1 by 3 is 3 by 3, 3 times 1, 3 times 1 in the exponent crossed out, and we end up with 6. Same way, instead of doing all that, we can directly cross out the radical or the root with the exponent what we have here. Also cube root and 3 crosses out. If it is 2 root of something like 5 square, crosses out. So that's how they cancel each other. If you have any doubt, you can go through this thing about radical to exponent thing. Now here, x root, I mean sorry, root x, that's going to be x power 1 by 2. Radical is nothing but denominator of the exponent. So here nothing is there, so we call it as square root, so 1 by 2. Cubed root, so exponent is 1 by 3. So let's see, what about x power 2 by 3? So for x power 2 by 3, we separate it like applying x power whole power n rule, the power rule. We are going to separate it. It's actually combined x power mn. So we are going to apply x power whole power n. This power rule we are going to apply. So it's going to get separated x square and x power 1 by 3. So 2 inside, whole power 1 by 3. You can write in any order 1 by 3 inside and whole power 2. That also fine. Now 1 by 3, exponent is 1 by 3. So that turns into cubed root. So cubed root of x square. What happens if you take the same question? If the 1 by 3 inside and square outside, nothing happens. It's still cubed root and whole square. Mostly we are going to follow these kind of thing with this. I mean, out of this two, we use mostly this. Let's see example number 3. Which of the following is equivalent to fourth root of x power 5? So you have option A, B, C, D. We have to choose one fourth root. So just now we learned that fourth root, if you turn it into exponent, it will become the denominator of the exponent. So it's going to be 1 by 4. Now apply the power rule, 5 times 1 by 4. So that's going to be 5 by 4, which is option C. Let's see example 4. The expression 25 power 2x divided by root 5 whole power x is equivalent to 5 power kx, where k is a constant. What is the value of k? So we need to find k value is how much. So we can able to find only when the base of the RHS and the base of the LHS is same, then there is a chance of getting the value of k. So how can we get that? Here 25 is there and here 5 is there. So we try to get the compound value of this as 5. Let's see, let's try to solve. It's going to be 5 square. We can write 25 as 5 square whole power 2x divided by this root 5. I'll write it as exponent 5 power 1 by 2 whole power x. That's going to be 5 power kx. So here 2 into 2, 4x, 5 power 4x divided by 5 power 1 by 2 x. multiply. I applied power rule here. X power whole power n equals to x power into n. 1 by 2 into x, 1 by 2x. That's going to be kx. Or else I'll write here it as x by 2 directly. So now here are same. So we can apply quotient rule. X power divided by x power n, that's going to be x power minus n. So apply quotient rule. So 5 power 4x minus x by 2 equals to, here this is 5 power kx. 5 power kx. So on solving this, 4 2 is 8x minus x divided by 2, that equals to 5 power kx. So 8x minus x, it's going to be 7x by 2. 5 power 7x by 2, that equals to 5 power kx. You can see in LHS and RHS, bases are equal. We can equate powers. So 7 by 7x by 2, that's going to be kx. So cross out this x, k value is going to be 7 by 2. Example 5. If the square of a is equal to the cube of b, square of a equals to cube of b, where a value is greater than or equals to 0 and b value is greater than or equals to 0, for what value of x is root a power x equals to b? Then for what value of root a power x that equals to b, they're asking us to find what's the value of x. So we have this information. So I'll try to do cube given information. So I'm going to get cube the root of a square, that equals to cube the root of b cube. So I'm going to get the value of b. Why I did cubing on both sides? If I get the value of b by crossing out this cube the root and cube, I get value b. I substitute that here. I solve things with only a and I get the value of x. So this is going to be a power 2 by 3 directly square and this 1 by 3. That's going to be b. So I got b value is a power 2 by 3. I'll just substitute this in the place of b, a power 2 by 3. Here this is a power x by 2. Why a power x by 2? This radical turns into 1 by 2 and here already x is there, so x by 2. So now bases are equal, equate powers. Bases equal, equate powers. So x by 2, that's going to be 2 by 3. So x equals to 4 by 3. Let's discuss about how to simplify square root. You can see square root of 48. So write down the factors under the square root. How to get the factors? Try to do factorization by using short division method. So if it is 48, start with the least prime number. 2 times 24 is 48. Continue with the least prime number till it breaks. 2 times 12 is 24. 2 times 6, and then 2 times 3, and then the least prime number 2 doesn't work, so go with 3. So 3 times 1, next least prime number I've gone with, and then I got these numbers which are 4 2s and 1 3 placed in under the square root, and out of them taking a pair of them and moving out 1 2. From this pair I moved 1 2. You can't take 1 3 out of the square root. You need a pair to take it out of the square root. If it is if it is a cubed root, you have to take out a 2 out under from the square root. From the cubed root, you need to have three roots, three twos under it, so that you can able to take a 2 out of it. So why like that? Because let me tell you, let's break this thing. If we break this, it's going to be 2 and 2 square. I separated it, 2 2 square, and then this way. So I just took two twos and I can write it as 2 square, right? So I just wrote and then cross out this 2 and square root. 2 square root cancels out. So you got 2 times 2 times root 3. So instead of doing this directly, a pair of 2 gives you 1 2 out of the square root. A 3 twos from the cubed root will make you 1 2 out of the cubed root. So same way. So or else you can do this 48 as 4 times 4 times 3 as factorization thingy, and then we take 1 4 out and directly 4 root 3. Here also same thing we got. It's up to individual what way they want to do. If you want quicker, you can go with this, or else you can go with that one as well. For root 72, what we are going to do, we are going to do the short division method. So start with the least prime number 236 and then 1. So 6 to 36 72 to 18 16 to 9. So we are going to take 2 till it breaks. So 2 not going to work. So the next least prime number is 3. 3 threes, continue with 3, and we done. So 3 twos, 3 twos, and 2 threes. 3 twos, 1 2, 3 twos, and 2 threes. So what I'm going to do, take 2 threes out, take 2 threes out, 2 twos out. From that pair you get one of them out, so it's going to be 2 3 root 2. It's going to be 6 root 2, just like the way we did it for root 48. You can do it in other way also, root 36. Here it's going to be 6 and 72 to 36. So 6 times 6 616. You can go this way also. You can take 2 6 and 1 2. So it's going to be 616 comes out from the square root. It's going to be a pair of numbers, gives you one number out of the square root. So it's going to be 6 root 2. So it's only 2. We can't make it single 2. It must be under 2 only. Same way for cube the root of 16. So 16, if we do short division method, 2 8s, 2 4s, 2 2s, and 2 1s. So 4 2s under the cube root. So three of them. Why like that? This three of them we write like this, 2 2 2, and we write 1 root 2 separate. It's still same. So cube the root of 2 cube times root 2. So cube and cube the root cancel off. So 1 2 out. So you need to have a triplet, which means three of them as 2's. So you can get 1 2 out of it. So 2 root 2. 2 cube the root 2 will be the answer. This is how we solve square roots. Example 6. Which of the following is equivalent to x square whole power 3 by 4 where x value is greater than 0? So the given x square whole power 3 by 4. After watching this, definitely we get a that apply power rule and multiply them. So it's going to be 236 6 by 4, x power 6 by 4. 6 by 4 is nothing but x power 3 by 2. So you ended up with x power 3 by 2 from the options, which gives us x power 3 by 2. If you go with option A, it is root x. Root x is nothing but x power 1 by 2. So it's not matching. So it's not option A. Going with option B, x root x. So which means x multiplied by x power 1 by 2. Bases are equal. So we can add up using the product rule. So it's going to be 1 plus 1 by 2. Nothing is there in the power, means we can consider it as 1. So that's going to be x power 3 by 2. So it's matching. So it's option B. If you check with option C, cube the root of x square, that's going to be x power 2 by 3. That's not matching with x power 3 by 2. So no. Option D, fourth root of x, it's simply x power 1 by 4. No, we need x power 3 by 2. So it's option B. We already discussed about negative 3 parenthesis whole square and negative 3 square. We know that if it has a parenthesis and a square, the answer end up with 9. If the negative sign and 3 square without parenthesis, the answer end up with negative 9. And also we discussed about comparison of odd versus even exponents. So using this concept, we are going to solve exercise 1. So I just want to repeat this. If the exponents are odd 3 5 7, for the same number negative 2 as a base, we end up with negative as the output, negative number as the output, negative 8, negative 32, negative 128. You can see exponent is 3 means the thing which is inside the parenthesis, we have to multiply to itself for 3 times. So here one negative, two negative, positive, and there is one more negative. This is positive and this negative gives out negative. Same for the second and third. So whenever there is a odd exponents, directly you have to give negative as a sign for the final result. You just do the multiplication part after that. If it is even, directly you give positive sign as the final result. You see, exponent is positive 246. You see the sign, it holding positive sign. So don't calculate it, you just based on the even exponent, just give the output as positive, and then you just calculate. Even if you calculate for the negative signs, negative, negative, positive, negative, negative, positive, so you end up with positive result. However, even if you calculate in the longer way, however, you need not do in that way. Directly, if it is even exponent, give the result as positive sign. If it is odd exponent, give the result as negative sign. Let's go ahead and solve exercise 1 with the help of this concept. So exercise 1, we have to solve this without using a calculator. First one, negative 1 whole power 10. So here what is exponent? It's an even exponent, so directly output is 1. Output is positive, sorry. Output sign is positive. So negative, you need to multiply 1 to itself 10 times. If you multiply 1 to itself 10 times, you end up with 1 only. So the answer is positive 1. So here the exponent is odd, so directly you end up with a negative sign, and then 1 multiplied by itself any number of times you get 1 itself. So just I'm writing even exponent positive sign, odd exponent negative sign. So here again even, so the answer is positive sign and then 1. Here you need to be a bit careful. Here this is a bit different. Here negative is separate, it doesn't have a parenthesis, and 1 power 8, which means negative separate and 1 multiplied to itself 8 times. So however you get what answer? 1 itself. 3, 4, 5, 6, 7, 8. So this is going to be you, this minus is separate, and then 1 multiplied to itself is separate, so you multiply that, you end up with negative answer. Be careful. And now here there is two minuses, one is outside the parenthesis, one is inside it. So however, let's go ahead and solve. First, just keep the first negative sign as it is, don't change anything, and then inside the parenthesis, power, I mean the exponent is even, so you end up with positive 1. I just solved the parenthesis part and I got positive 1. Now, however, the negative and the positive will give out negative. Negative times positive is negative, and you end up with negative 1. So, negative 3 whole power 3. So, that's going to be, what is the meaning of that? If the exponent is 3, negative 3 is multiplied to itself 3 times. So, this is what we get. So, minus into minus plus, and this plus, and there is a minus, though that's end up with minus. So minus 3 into 3 is 9, 9 into 3, 27. So negative 27 is the answer. Or else you can directly do 3, 3, 3, 27, and odd exponent, it's going to be negative 27. I just did it a bit long. That's fine. So be careful. Sometimes they won't give you parenthesis. You see here, there is no parenthesis. So the answer going to keep that negative sign as it is. Don't do anything with that. Now you have to do this separately. The negative, this thing applied, this thing is applied, only parenthesis is given. Works when parenthesis exists. If there is no parenthesis, just keep that negative sign as it is. See here, I just wrote negative sign as it is, I didn't change it. And 3 into 3 into 3, it's directly 27. 3 3 is 9, 9 3 is 27. Coming to question number 8. Question number 8, minus outside as it is. So here again parenthesis is there, square is there, even exponent, so it's going to be positive 6 into 6, it's going to be positive 36, end up with positive into negative is negative 36. Now coming to the next one, negative again outside as it is, odd exponent, so it's going to be negative 4 power 3. You need to multiply 4 to itself 3 times. So 4 into 4 into 4, 4 4 16, 16 4 64. Now it has negative sign, negative times negative, that's going to be positive 64. So now 2 cube, what is the meaning of 2 cube? 2 you need to multiply to itself by 3 times. So 2 into 2 4, 4 into 2 8, and then multiply again. So 3 into 3, 3 square, so 9, and then negative 1 whole power 5, odd exponent, so you end up with negative, and 1 multiplied to itself 5 times, you end up with 1 itself. 1 into 1 into 1 into 1 into 1. So it's -1 itself. I mean, you end up with 1, and because of the odd exponent, you get negative. So now 8 times 9 is 72. 72 into 1 is 72 itself, and there is a negative sign. So you end up with -72. Now 4 power -1, that's going to be 1 by 4 power 1. So turning a negative exponent to positive, it turns to be 1 by 4 power 1. This is what happens. Why it happens like that? And also, question number 12, 5 power 0. Anything to the power of 0 is 1. But why? Why this is happening? Let me tell you. Let's talk about power with the negative exponents. You already know that, let's say 10 power 3 is there, equals to 10 into 10 into 10, that equals to 1000. You know that. So I want to decrease this 3 to 2. You see below it, here it is 2. When I decrease that, it's going to be 10 into 10, because exponent is 2, so base multiplied to itself is twice, that's going to be 100. Now I decrease 2 to 1, so it 10 is multiplied to itself one time, so 10 into 10, 10 into 1 is 10 itself. What do you notice from 1000 to 100? It is getting divided by 10, you get 100. From 100 to 10, from 100 to 10, what you notice, 100 divided by 10 is 10. So that's how, in the same way, now 1 to 0 I am reducing. So here, so whenever it is 3, you have 1000. Whenever it is power 2, it is 100. So what do you notice here? It's getting divided by 10. Whenever it is 1, it's getting divided by 10. 100 divided by 10 is 10. In the same way, this one also, 10 divided by 10, that's going to be 10 to the power of 0 is 1. Like, this is how it works. So what it's going to be, 10 power -1, it's going to be 1 divided by 10, so that's why 1 by 10. So we just followed the pattern to get the next numbers. If it is this, it's going to be 1 by 100. I'll just show you with another example. You see here, 3 cube, 3 into 3 into 3, which 27. 3 square, which is 9. 3 into 3, 9. But this 9, if you divide the 3 cube, which is 27, divide by 3, you get 9. For the next one, you divide the 9 by 3, you get 3. 9 divided by 3 is 3. And you also see this 3 turned to 2, 2 turned to 1, and 1 turned to 0. Keep on subtracting 1. That is the pattern it's moving with. And here also, dividing by 3 continuously happening. So for the next one, in this, it's 3 divided by 3 is 1. That's why 3 power 0 is 1. And if you go for the next 0, subtract 1, I mean, go one step down to the 0, that's -1. 3 power -1. 3 power -1 means here you got 1 as the result, divided by 3, that's 1 by 3. So if you go for the next step down, for the one, go one more step down, that's going to be 3 power -2. So 3 power -2, you got answer previously 1 by 3. So divided by 3, that's going to be 1 by 3 square. Like, we saw a pattern it's going with, we continued that pattern to get the value of 3 power 0. So 3 power 0 is 1. You can check it later. I'll give you the notes as well. So hope you understood why 4 power -1 is 1 by 4, or 1 by 4 to the power of 1, and anything to the power of 0. Anything to the power of 0 is 1, because 5 square is 25, 5 power 1 is 5, 5 power 0, it's getting divided by 5, 5, 5, by that pattern, so you get 1. So here, coming to question number 13, so 3 power -2, that's going to 1 divided by 3 square. So whenever you see a negative power, that turns to be a denominator and the positive exponent. So this one turns to be 1 by 2 whole power -1. First step, you just have to distribute this -1 to inside of the numerator and denominator, instead of the whole bracket, to numerator and denominator. So 1 by -1 will be 1 divided by 1, and 2 by, this will be main and main by thingy, and then 2 power -1 is 1 by 2. This is going to be 1 by 1 multiplied by 2 by 1, that's going to be 2 by 1. The answer is 2. If you want to do directly, you can do it directly one, so it get reverse, the thing get reversed. the thing numerator will become denominator, denominator will become numerator. That's going to be 2 by 1. Directly you got it. Same thing, you can do it directly. So it's actually 3 power 2, 4 power 2. The number what is there inside in the form of fraction, I just removed this negative sign and I reciprocated. That's going to be 9 by 16. If you're not comfortable with this, I'll just write few more steps for the same thing. 4 by 3 whole power negative 2. So just split that negative 2 which is outside the bracket to both for the numerator and denominator. This turns to be 4 square and this turns to be 1 by 3 square. So it's going to be 1 by 16 and then 1 by 9. That's going to be 1 by 16 times 9 by 1. That's going to be 9 by 16. Fine. Exercise 2. Simplify so that your answer contains only positive exponents. The first one has been done for you. You can see here the first question, 2k power negative 4 times 4k power 2. What they did, the meaning of negative 4 is 1 by k power 4. So that's why here k power 4 is in the denominator. Rest 2 into 2 times 4 k square is in the numerator. 2 times 4 is 8 k square and k power 4. It's going to be k square itself. Like you can apply the quotient rule. That's going to be k power 2 minus 4. That's equal to k power negative 2. K power negative 2 means it comes in the denominator itself, or else you can cross out with the basic thing. Here you can cross out k square and here you can cross out k square, so you end up with k square itself. So now we are going to solve the upcoming questions using these laws whatever we learned previously. Let's start solving question number 2. So here just multiply numericals, the coefficients 3 and 2. 3 times 2 6 and x square and x power 3. Here I'm going to use product rule, x power n, that equals to x power plus n. So here x bases are same just like this, so I'm going to apply that rule. So x power 2 plus 3, that is going to be 6 times 2 plus 3 is x power 5. So now second one I do same way, I multiply these two numbers which is 15 and again same rule x. So I just apply the same rule, x power plus n, because x is same, I just add up the exponents. It's actually 4 and minus 2 is there, so that's going to be 15 times x power 2. So now coming to example question number 4, 7 times negative 3. Here they didn't mention dot but I mentioned it now. So 7 times 3 which is equals to 21 and there is a negative, so I just keep negative here. Now 7 power raised to the power of 3 and raised to the power of negative 3. So that's going to be raised to the power of negative 3. It's again itself. So I'll just add up the exponents here, positive 3, negative 3. So that's going to be negative 21 raised to the power of 0. So raised to the power of 0 means anything raised to the power of 0 is 1. So I'm just placed in place of that 1. So negative 21 times this 1, you end up with negative 21 itself. So coming to question number 5, 2x square whole raised to the power of negative 3. So you just have to distribute this negative 3 to 2 and x term as well. You have to distribute it to each and every individual term inside the parenthesis. It's like this one, you see here, the which is on the top is distributed to the inside each and every term of the parenthesis. So what do we get if we distribute 2 power negative 3 and x square whole power negative 3? That's going to be 2 power negative 3 means we are going to get 1 divided by 2 pi 3. That's what we learned. If it is x to the x raised to the power of negative exponent, then if we turn it into positive, it becomes 1 by x. That's what I wrote. In the exercise 1, I clearly said why negative exponent turns this way. You can watch it. Now 1 divided by 2 raised to the power of 3 times, and here I'm going to apply x square whole power negative 3. So here I'm going to apply this power rule, x raised to the power of whole raised to the power of n. So multiply mn. So I'm going to multiply this 2. So I'm going to get x raised to the power of negative 6. So x raised to the power of negative 6. So finally I get x raised to the power of negative 6 divided by 2 power 3. 2 power 3 is 2 times 2 times 2. So I end up with x raised to the power of 1 by 8 x raised to the power of 1 by 6, x raised to the power of negative 6 means it will be times x power 6. It is negative, it turns into denominator. I drew it directly 1 by 8 x power 6. So question number 6, negative 3 and here a positive 3 and both get multiplied. 3 times 3, it is negative 9 because of negative here. And then a square, a power negative 5. I just apply this one, x power n. I'm taking the bases equal. I'm not considering a square and b power 8. No, we can't do that. Bases must be same. This a square and a itself base. So it's going to be a power 2 minus 5 and b power negative 3 and positive 8. So we end up with negative 9, a power 2 minus 5, which is negative 3, b power negative 3 plus 8, it's going to be positive 5. So negative a, negative 9, a raised to the power of negative 3, b power 5. So if we write this, negative 9b power 5 divided by a cube, because this a raised to the power of negative 3, if we turn it into a positive, it will be 1 by a cube. So question number 7. So there is no change in the numerator, but denominator, this outside, I mean the exponent, you have to multiply with this because we are going to apply power rule. So on applying power rule, it's going to be x power negative 4, and you can see x power 4 and x power negative 4. Here bases are same and they are in the numerator and denominator, so I'll apply quotient rule. So this 3 will be as it is, so x power 4 minus of minus 4, so I will get 4 minus of minus 4 is plus 4, so 3x raised to the power of 8, 3x raised to the power of 8. So this one again same formula, x in the numerator denominator. I apply the quotient rule, x raised to the power of 3 by 2 minus 1 by 2. So that's going to be x raised to the power of 2 by 2, that equals to x raised to the power of 1, which is x. Coming to question number 9. So 2 times 3, which is 6, and no. Here there is a exponent 2 which you have to give it to the individual terms inside the parenthesis. We have to apply this formula here. So this is going to be 2 square and 2. This is one term, and then this one again same thing repeat. 3 square power 3 is there, and for that you have to square it up. So you ended up with what? 2 square, which is 4 square, and then 3 square, which is 9. 3 square 3 is 9, and power 6 we are going to apply power rule for this. So that's going to be 3 m power 3 into 2 m power 6. So 4 times 9, which is equals to 36, and power 2 and 6, just add them up. So 36 m power 8. How I got power 8? I applied product rule. So now question number 10. So again there is a exponent, so we just have to split it to both terms which are inside the parenthesis. So a power negative 1 whole power 2 times a power negative 2 whole power 2. So a, now apply the power rule. So that's going to be a power negative 2 directly, a power negative 4. So that's going to be a power negative 6. So I just applied the product rule. That's it. I applied power rule here. 1 times 2, negative 1 times 2 is negative 2. Negative 2 times negative positive 2, which is negative 4. And then I just applied product rule, negative 2, negative 4, that's a power negative 6. 11th question, equals to negative 3 is in the exponent, so I have to distribute it. So however there is only one term, so instead of that directly we'll apply a product rule. So x power mn equals to x power n, x times n. So negative and negative positive in the exponent, and 2 3 6 b power 6. Same thing here, b power 6. So here base is equal, so apply the product rule. So it's going to be 6 plus 6, b power 12. And then here same thing, just give it, split it inside to the terms. So it's going to be square whole power 3 n cube, and then split the same thing 2 to each term, so become square and become 2 whole power 2. So what it finally become, power 6 n power 3, because I applied power rule here. And then in the denominator it's only square and n power 4. So now you can cross out like Here you can cross out 2, here you can cross out 2, 4 is remaining on the top, and here 3 n's you cross out, here 3 n's you cross out, 1 n is remaining, so you end up with answer 4. Divide by n, or what you can do, you can apply this for this one quotient rule. For this n1 you can apply quotient rule. So if you apply that, 6 minus 2, however you get power 4, 3 minus 4 you get negative 1. So negative n power negative 1 means still divided by n only. Whichever is comfortable for you can go with that. Question number 13, it's simple. Instead of doing applying the rule of quotient, you can simply cross out and do it as well. So 1m you cross out, so that's going to be, here remaining 1m is remaining 1n, and here 3 n's are there, only 1n you have to remove, so it will be n square. So 1 divided by mn square. If you want, you can separately apply the quotient rule for this and this one, even you still get same thing. It's better to go with the cancellation, gives you direct answer quickly. So this one also, here negative 2, so it means 1 by k power 2, and it is 1 by k power 3, that's going to be 1 by k square and k cube by 1. So k cube by k square. So if you do apply this quotient rule, you get k, or you can directly cancel, square square cancel, in the numerator still 1k left because 3 k's are there on the numerator. What you do in this case, instead of doing this all, you can directly reciprocate. What do you get? Whenever two negative signs you have, this becomes the denominator, it will become the k square, and the numerator will become the k cube. Removing the negative signs, you directly write the k cube on the top, the denominator become the numerator become the denominator without the negative sign. That's the step you can directly do it for these kind of questions, when especially numerator and denominator have negative signs. Now coming to 15th question, it's better to do directly. So take this x and x terms, x power 2 and then minus of minus 3, and then y power 3. I just apply the quotient rule for that. For this second thing also I'm doing same, y power 3 and minus of minus 4, and I'm going to do same thing for the third one. It's to us what to do to get the solution, whichever you are comfortable. Maybe sometimes for some situations cancellation is a comfortable, sometimes for some situations going with quotient rule is comfortable. So this is going to be z power 4 minus of minus 5. So what do we get? X power 2 plus 3, it is minus minus plus 2 plus 3 5, y power 3 plus 4 7, z power 9. So in this situation it's better to go with this way to avoid confusion, because one is in positive in the numerator, one is in negative in the denominator. So whenever it is positive we can cross out, or we can do some reciprocation. But whenever one is positive, one is negative, you better go with this way. I mean, definitely use quotient rule, which helps you to get the answer quickly. Done with exercise 2. Exercise 3, simplify the radicals or solve for x. So we have to solve the radicals and some values of x. So first of all, to solve a radical, what do we need to know? So the number which is inside the rad, under root or under root, you have to solve that. How you're going to solve it? So you have to do factorization. You have to turn the given number into prime factors. The given this number, we have to turn it to prime factors. How we are can able to turn this into prime factors? So let's see. I use division method to get the prime factors. So 2 times 6, I start with the least prime number 2. 2 times 6 is 12. So I just divide it, and again I go with this least prime number 2 times 3. If I go with 2 again, it's not going to work. In 2, 3 doesn't come. So I go with the next least prime number, which is 3. 3 times 1 is 3. So I got some prime factors on the left side. I will place them under this rad, or you can call it as under root. So below the rad, I'm going to place 2 times 2 times 3, which are my prime factors. So now this is a square root, which means 2 root. So it's going to be like this. I'll take this 2 into 2 separate, and then multiply it by root 3 separate. Why like that? Because this makes this 2 into 2, we can turn it into 2 square, and the square and rad gets cancels off, because this rad is 1 by 2 when you turn it into an exponent. So it means 2 power 2 whole power 1 by 2, even though this thing cancels out if you do it in that way. I'm just doing it directly. So that's going to be, here we still have 2 and then root root 3 is still there. We can't do anything, just leave it like that. So we end up with 2 root 3. Same way we solve for other values. Let's solve for 96. I do same. I do short division method, and then I'm going to write the prime factors for this number by using short division method to get the prime factors. So it's 96. I go with the least prime number 2, 2 4 8, and then 116, 2 8 16. 2 times 2, 2 times 4. Again I keep on move with 2 till I get till it doesn't work. So 2 times 6, and then 2 times 3. Now it doesn't work, I go with 3, the next least prime number. So after solving this, I got prime factors. So that's going to be 2 into 2 into 2 into 2 into 2. So 1 2 3 twos, 2 twos and 1 3. So total 5 twos and 1 3. What I'll do is I'll take 2 2 separately. These 2 twos separately, it's going to be root 2 whole square, and again 2 root whole square. That equals to again 1 root 2. 4 twos done, fifth root 2, and then root 3 I write it separate. So now why I'm writing like 2 twos, like power twos? Because I can take 1 2 out by doing this way. So I end up with 2 into 2 into root 2 into root 3. So that's going to be what? 4, and then we can't do anything. So 4 root 6. So answer is 4 root 6. So this is you solve. Try solving 3, 4. Let me solve 5. So that's going to be same thing. I do same. I just get the values of, I mean the prime factors of 75. Here the digit is 5. Definitely it's not going to work with 2. So I start working with 3. So 3 it works. So 3 2 6, and then 3 5s, and 3 it's not going to work. So the next prime number is 5. So 5 times 5. So 5. So I got 3 outside. Here there is a 3 outside, and then 75. 3 into 5 into 5. These are my prime factors, 5 5. So we can take directly 2 5s are there directly, instead of writing for root 5 square or root 2 square and then take out 5. We now will try directly take 1 5 out, because 2 5s are there under rad or under root. So we can take 1 5 out. So out of that I'm taking 1 5 out. If I take from this, it's going to be root 5 square. So root and square off, you end up with only 5, and then this under root 3 will be same. So I end up with 15 root 3. So you just try question 6. Let's solve question number 7. We have to find the value of x. We have to solve for the x. So how do we solve for x? Which means we just have to eliminate this rad. Then whatever the value is there on the LHS, that's going to be the value of x. So what we have to do to remove this rad, to remove that rad, the indirectly the value of that is 1 by 2. I mean in the exponent for that x. If we do the squaring on both sides, then we can eliminate this, and then we get the actual value of x. So what I do is I will square on both sides. On applying square on both sides, you have to do the same thing again. Individually you have to give square to this and as well as this. When you give it to the 5, it's going to turn to 25, and root 2 square is going to be 2. Root 2 square, square and root off, so you end up with 2. And then here square and root off again, you end up with x. So finally your x value is 50. So same way we are going to do this one also. We just have to apply whole square to it, and then we get it. So if we apply whole square, so we are going to get whole square. 3 square is going to be 9 times this under root x square. What happens under root x square? Under root x whole square, the square and root of, you end up with x. That's going to be the square and root again of, that's going to be 45. 9 times 1, 9 times 5. So directly x equals to 5. This is one way. What is the other way of solving is, we just have to find the value of 3 root x equals to root 45. We actually have to find the value of x. So what we do, we have to remove this 3, we have to remove this rad, then we will get the value of x. So how do we need to do? Just forward this 3 to other side. It's in the multiplication, it's become division. So it will be turning into root x or rad x equals to root 45 divided by 3. So now you have to remove this rad also. What we do? Squaring on both sides, just square up. So if you square up the square and root of for this, but you this square is not only for denominator, it is numerator, it is also for numerator denominator. So when you do that, when you apply the square for numerator and denominator, you end up with x value equals to, in the numerator you cross out the root and square, you end up with 45, and this becomes 3 square, which is 9, 9 ones, 9 fives, x equals to 5. So that's method 2. Actually method 2 is better, because you just have a target that removing things which are with x, so that you'll get the value of x. That means you are just isolating the value of x. So same thing here, you need the value of x. Try to remove this root, try to remove this 4, the value what you get, that will be the value of x. So let me try question number 10. So I just want the value of x, so I just have to remove 2, I have to remove root or rad, remove 3. So I'll just try removing one by one. So let's transpose this 2 to other side, or else you can directly cross out 2 times 1, 2 times 2. So what do you have? 2 root 6, that equals to root 3 x. So now you have to remove, you can't directly remove 3. First you have to remove the under root or the rad. How to remove this? So whole square. Apply whole square on both sides. Then what happens? If you apply square for this, this becomes 4. And if you apply the square for this, that becomes 6. That's going to be 4 and times 6. That equals to, if you apply for this, it's only for directly rad you will apply whole rad, so directly it's cancel off. You can't apply individually like this. Even if you do that, how it will be individually? Let me write root 3x whole square, then you have to write root 3 whole square, then you have to write root x whole square, then square this square root of, then you end up with 3x only again. You got it? So I think, yeah, that's it. So here there is no equal, I have to write there, that equals to 3x. So now you have 3x here, you can cross out 3 times 1, 3 times 2. Finally you get x value equals to 8. 4 times 2 is 8. Question number 11. So same way, we just have to remove this root 2 thing. So we get the value of x. So what we do, 3 root 8, I just divide root 2 on both sides, so that this will be off. So I will get root 2 here, that equals to x. So what do we get? If we solve this part, that's going to be 3, and root 8 by 2, which is 2 times 1, 2 times 4, that equals to x. That will be 3 root 4 equals to x. 3 root 4 is 3, 4 value is 2. So 3 into 2, that equals to x value equals to 6. Hope you know root 4 is 2. Root 4, that equals to root 2 into 2. So that equals to root 2 whole square. That equals to 2. Square root cancel. For this, how do I get that? Same way how we did in the beginning. For 12, what we did? We applied this thing and we got the factors. Same way for 4, if you do, what do you get? 2 times 2, 2 times 1. That's what the factors are, 2, 2. That's how we get this value. So now coming to 12th question, it's a bit different. Let's see. So here you can see x power 1, and this one I'm going to write it as x power 1 by 2, that equals to 216 whole power 1 by 2. What I'm trying to do is, here 2x are given, but we just have to find the value of x. So I'm trying to make it united by taking the exponents. That's going to be, apply the x power n formula. It's going to be x power plus n. So it's 1 plus 1 by 2. So it's going to be 3 by 2 if you add that thing. So 216 whole power 1 by 2 will be same. So 216 whole power 1 by 2. So I just want to do what? Same story. The thing which are with the x, we are going to remove that part. If we remove this part, we are going to get the value of x whatever left. So to remove that 3 by 2, just like the way how we are doing here, what we did, squaring on both sides, right? Here we did squaring on both sides, so that we can off this under root or rad. So same way we use this, but here we are not going to do under squaring on both sides, but instead we are going to do 2 by 3 as exponent on both sides. This is what we are going to do. Why? Because this x power 3 by 2 equals to 2 power 1 by 6 whole power 1 by 2. For this, we are going to do 2 by 3. Power exponent will be 2 by 3 and exponent will be 2 by 3. So what happens? We can apply the power rule for this, and 3 to 6, 3 to 6 in the numerator denominator both off. 3 3 cut, 2 2 cut. You can cancel off or you multiply and then also cancel off, you still get the only x. Now you got the value of x. Whatever you have on the right side will give you the value of x. This 1 by 2 and 2 by 3. 1 by 2 times 2 by 3, off you get 1 by 3. So it's going to be 2 power 216 whole power 1 by 3. What do you mean by 1 by 3? It's cubed root. This is cubed root of 216. Now we are going to do the short division method to get the prime factors. So 216, I just start with the least prime number and I solve this. 2 5s, 4, and then 2 is not going to work. I go with 3, 3 nines, 3 threes, 3 ones. So what do I have? I have 3 twos, 3 threes. So if I put that under the rat, that's going to be 2 into 2 into 2 into 3 into 3 into 3. I just want to make it simple. Here, whenever it is under root, you learn under root whole square is going to be 2. What does this mean? It is that is 2, but actually under root 2 whole square, that is equals to root 2 root 2, that equals to root 2 into 2. So for this value you can cross it out, but here it is cube, which means cube the root of 2 into 2 into 2, which gives us cube the root of 2 cube. So we can cross out this, you get the value of 2. So here you will get, for this 3 twos you get 1 2 out of the root. For this 3 threes you get 1 3 out of the root. So the answer is 2 3 6. X value is 6. If you don't understand solving it here, you can check it. So cube the root of 2 into 2 into 2 into 3 into 3 into 3. So I'll just separate it. Cube the root of 2 into 2 into 2 and cube the root of 3 into 3 into 3. So this value cube the root of, I can turn it as cube, and cube the root of 3 cube. So this, what does this will become? 2 power 3 whole power 1 by 3. So 3 times 1 by 3 is how much? 2 power 3 by 3, which is off, and then you end up with 2. That's what I directly took 2 here. And then this also same, 3 power 3 whole power 1 by 3. Why? This root 3 is going to be exponent of that, so it's going to be 3 3 out, you get directly 3. So that's how I wrote. But you need to remember one thing, when it is cube, so 3 twos, 3 threes. But in previous case here, 2 twos and it's a square root, that's how they are getting cancelled. Square root of 2 into 2, so you can write square root of 2 square. This is square root. Whenever it is square root, we don't mention 2, but it means it's a 2 is there in that place. So be careful in that thing. Let's start exercise number 4. First question: which expression is equivalent to x square y times x power 4 y raised to the power of negative 3, where x, y, and z are positive numbers? So given few options here, so out of them, which is equal to the question? So what we do, we just solve it. This x and x, so we end up with x power 6, because applying product rule, 2 plus 4 6, and y power negative 3. 1 minus 3, nothing is there, means 1. So here 1 minus 3, that's going to be negative 2, y power negative 2. So it's matching with option B. Question number 2: which of the following is equivalent to under root x by 64 for all x greater than 0? So here the given question is under root x by 64. This is equal to one of the option, maybe A, B, C, D. So how to get it? So here there is 64. We have some idea about 64. If we do something like root x and root 64, like if we split the root, we get on the top it's root x only, it's going to be 8. So wherever there is 8, we can have a chance. So maybe we guess A or C, because its denominator is same. And then the numerator is x power 1 by 2. Yes, what is the meaning of root x? It's x power 1 by 2 if you turn it into exponent. So it's matching with option C. It's not matching with option A, definitely. Even if it is denominator is 8 and the numerator is x square, so that's going to be not matching with this. Definitely we have root x or x power 1 by 2. It's not C and D, it's not matching the denominator part. Question 3, which expression is equivalent to this where x not equals to 0? So we just have to solve the given expression and see that equals to which option. So x power 5 by 6 divided by cube the root of x, that equals to x power 5 by 6 divided by x power 1 by 3. I just turn this radical to exponent, and now you can see bases are same. You can apply the quotient rule here. So it's going to be x power 5 by 6 minus 1 by 3. So that's going to be x power 15 minus 6 by 18, that is 9 by 18, which is 1 by 2. So it's option A. Number 4, which expression is equivalent to b power 9 by 7 where b greater than 0? So here you see the options. Here option A, I'll just try solving option A and try to match with option B because it is a bit tough to get this value match with that. So let's try doing this way. So I'll just try b power 105 as it is, but I try this, turn this root 15 to exponent, it's going to be 15. The same way it will be same for this, it's going to be 135 divided by 15. It's same for this, 135 divided by 105. Same for this, b power 105 divided by 135. I just turn the root to exponent. So here 15 times 1, 15 times 7, and 15 times 1 and 15 times 9. So it's 7 b power 7 by 1. So obviously option A is incorrect. B power 9 by 1. So A and B are not working. Coming to C, so we just tried with 15. Why can't we try this with 15 again? Because 105 and 135 just now we did, it works in 15. So 15 times 7 and 15 times 9, directly we get it. So it's going to be b power 9 by 7. It's matching with the given question. So option C is right. This is going to be 15 times 7 and 9. Option D, you're going to get b power 7 by 9. So it's, which is incorrect. No. Which expression represent the product of this and this where B, C and D are positive? So here you just have to product these two things. I mean two expressions what they given. I just try to take this b power 6 and b power 8, which is going to be b power 14. I can see in all of them b power 14 is there. Fine, I'll just go for the next one now. C power negative 2 multiply and then c power negative 3. I'm just applying the product rule. C power negative 2, c power negative 3, it's going to be c power negative 5. I can see in all options they given c power negative 5. Let's go for the next, d power negative 5, and then there is nothing here, just consider 1 and then you end up with d power negative 5. So here in option A there is no d power negative 5, d power negative 5. So obviously option A and B are incorrect. There is a chance that answer is B, C or D. So now what we have to do, we have to multiply this with this part. So we multiplied the first part with this first part. Now I'm going to multiply this with this. So b power 6, and there is no b power 6. So here b power 6 works here. It's there in option C, but it is not there in D. So D is incorrect, C is correct. It's not required to solve completely, so you can stop calculating here. Even if you want to go ahead and solve it, c power negative 2 and c power positive 4, you end up with what? C power positive 2. That's given in option C. C power positive 2. You see the last one, d power negative 5, d power positive 5. If you multiply that, you're going to get d power 0, which means 1. So it's 1. It's there. But C is not working. So option C, I mean D is not working. Option C is correct. Question 6. If x not equals to 0 and y not equals to 0, which of the following is equivalent to this? So we just solve this part. May one of them will connect with your solution. So let's start solving it. The given thing is 8x square divided by under root 4x power 6 y power 4. So here what I do is I just keep this numerator as it is, and then I just split this root 4 and root x power 6 and root y power 4. So that's going to give me 8x square divided by root 4 is 2, because root 4, that's can turn into 2 into 2, that's going to be root 2 whole square, square root done, you get 2, that's why root 2 in place of that. Now this value, the value what you see here, x root x power 6, I'll write it as x power 6 by 2, because this radical turns into exponent. So 6 by 2. The same thing will happen for the next one, y power 4 by 2. So what do you end up with? You finally end up with numerator 8x square divided by 2x power 3 and then y power 2. So 2 times 1, 2 times 4. This is going to be 4x square. And we can also remove this x term. Two x terms are there, three x terms are there in the denominator. So remove this 2 and then you still have 1x. So in the numerator you end up with 4 and divided by 1x in the denominator and y square. Does that option, do we have in options? No, we don't have any denominator in the option, so we have to write it one line. So it's going to be x power negative 1, y power negative 2 if you write it in the numerator. So that matches with option C. If and s are positive, which of the following expressions is equivalent to this? So you see this is equal to what? You see the common thing, the exponent divided by 7 for both cases. What does that mean? Which means it's the seventh root of r power 6, seventh root of r power 3. So we can write this as seventh root of r power 6, r power s power 3. Sorry, it's not r, s power 3. So it's seventh root you need to find. There is no such thing called division thing. So option C, D, A, C not right. And here it is 6 is there, sixth root no. Here option 7 have seventh root r power 6 s3. So yeah. So by seeing this exponent divide by 7, so you need to understand root 7 for both. Let's go for the next one. Root bth root of a equals to dth root of c. The given equation relates the distinct positive numbers a, b, c and d. Which equation correctly expresses c in terms of a, b, d? So you need to get the value of c, only c, in terms of a, b and d, which means indirectly they're asking the value of c. So how to get the value of c? So here, if you want c, you just have to remove what is extra with c. So how to remove that? So here dth root is there, d exponent d on both sides. I mean in the power place I'm going to put d. So bth root of a whole power, I'll keep d, and then here dth root of c, and I'll keep whole power d. So if I do that, this whole power d and this thing will get cut off. How come? Bth root of a, this thing I can turn it into exponent a power 1 by b whole power d, and then c power 1 by d whole power d. So if you multiply, however, this go off and you get only c. So the a value is d by b. So a power d by b is the value of c, which is option D. So I just did simple application. I want the value of C. So whatever the thing which is there with C, I try to eliminate by applying these kind of steps. Question 9. Which expression is equivalent to this? So it's so simple. Under root 16 a power 2 by 3, root 16, I just apply root 16. I mean, I'm separating the root thing, so it's going to be root a power 2 by 3. So this is going to be root 16 value is directly 4. Root 16 value is 4. Why? So root 16 equals to root 4 times 4. So this equals to root 4 square, that equals to 2. I just, if you've done the problems for the root values in exercise 3 with the help of short division method, hope you understand by now. You just apply this and do it. Short division method, 2 8s, 2 4s, 2 2s. So you got 4 2s, put that under root and then you can get the value of 2 2s out. So how obviously you end up with 4. Now a power 2 by 3 whole power 1 by 2. So this root, I turn it into exponent 1 by 2. This 2 and 2 cancels off. That's going to 4 times a power 1 by 3. So do you have that kind of options? Yes, option A matches 4 times a power 3. Rest doesn't matches. Question number 10. They given expression and they're asking us to find which is equivalent with the option. I mean, this expression is equals to which one among them? So you see root rs and root r. If you just solve that part, root rs times root r, so it's going to be root r dot s dot r. That's going to be root r square dot s. That's going to be root r square root s, square root of r root s. So we got, by solving this, multiplying this with this, we got r root s. R root s we can see that only in option B. Root s is not there in option C, option D, option A. So directly we eliminate A, C and D and we go with B. If you solve completely also you get same thing, plus root rs dot s. I'll write the question on the top. It's not required to solve till end. You just solve half and check with the options which is connecting with this, so that you can save time. So this is going to be root r dot s dot s, so plus root r dot s square. Now again separate r and then root s square, square root out, plus root r dot s. So this thing again we have in the option B, s root r or r, I mean s root rs, root rs. So both of them are existing in option B. It's option B. Question number 11. The expression cubed root of x square whole power n, where n is a constant, is equivalent to equals to x power 8. What is the value of n? These kind of problems you can solve only by completely making bases same. You see bases already same, but you just have to remove all those and make purely bases. What I mean is, I just try to make, turn this part into complete x raised to the power of something, so that it bases are completely, bases going to match completely, and then I apply the rule bases are equate powers. So cube root x square, so it's going to be x square whole power 1 by 3, cube root turned into that, so whole power n, that equals to x power 8. So multiply the inside part, x power 2 by 3 whole power n, that equals to x power 8. So again you multiply this 2. That's what we do, because we are applying power rule, 2n by 3, that equals to x power 8. You can see the bases are completely same. Bases are same, equate powers. So 2n by 3, that equals to 8. So that's how we get the value of n. If they ask something question related to exponent, to find the exponent value, mostly you use this rule to find it. So you need to get a thought while seeing these kind of questions. How can I make bases equal so that I can equate powers and get the value of that? So 2n equals to, this will be 24 and then 2. 24 divided by 2, which is directly n equals to 12. Question number 12. Which expression is equivalent to 2 power negative 2k dot, I mean multiplied by 3 power k? So you have to see here. Let's try solving 2 power negative 2k times 3 power k. After watching some options, let's try to solve this. 2 power negative 2 it is. So what it happens, 1 by 2 power 2k times 3 power k. So what I do is I'll just rewrite this as 3 power k and then 2 power 2k. I see that k's are the common power, so I'll just make it 1. What I mean is 3 by 2 square whole power k. Now that square, 2 square in the denominator will turn into 3 by 4 whole power k, which is option C. Even I don't know I'm going to get the value this way. I just started progressing the steps, slowly developing my steps, and I reached this point. I just took this as help in the beginning, and then I wrote this, and then I just some numerator denominator. I saw some k thing, power is common, I mean exponent is common. I turned it into 1, and then I got something like this, and then I checked with the options, it's matching. So that's how you just keep on improve your steps and connect, just keep on check the options, you reach the solution. So which expression is equivalent to a power 29 parenthesis a power 2 by 3 to the power of 2 by 3? So you have some options here, you need to check just by solving. There is no other way. A power 2 by 9 and then a power 2 by 3 whole power 2 by 3. So a power 2 by 9 we keep as it is, and we can apply power rule here. So that's going to be a power 4 by 9, and you can see here bases are same, so you can apply product rule here. A power 2 by 9 plus 4 by 9, that's going to be 6 by 9. 6 by 9 is going to be 2 by 3. So do we have any 2 by 3 kind of thing? So which means divide by 3 can turn into root. So here we have roots. It's not because root 9 we have 3. So cube here 1 by 3, cube root of a square. So cube root of a square will be the answer, which is option A. It's not B because it's not 16. So here, which expression is equivalent to this? So you can see some options. It's the common thing here is 2 by 3, 2 by 3, 2 by 3, 2 by 3 in all options. So this thing we need to eliminate, and we need to get something like 2 by 3 only. So how can we do that? If we watch carefully, this 4 and 9 we can write it as 2 square and 3 square, and here it's going to be 2 by 3 whole power a. Again you have to get 2 by 3 thing, only 2 by 3 you need to have in all, at the end after solving. So 2 by 3 whole square, I'll turn it into 2 by 3 whole power a. Now you can see bases are equal. 2 by 3, 2 by 3 bases are equal, so equate powers, bases are same. So we can add up by applying the product rule. 2 plus a, so 2 plus a, so that's option C, a plus 2. Coming to question number 15. So fourth root of x cube times 12th root of x power 5. The given expression is equivalent to root of x power n, where and n are positive constants each less than 10. M and n values each less than 10. X value is greater than 1. Find what is the value of by n. That's the final thing which we need to find. By equals what? So we need to find the value of and n. So here they given something in the RHS where and n are there. So how can we get and n? Which means we can this maybe x power n whole power 1 by, so that's going to be x power by n. We have some x, and we are working for something is in power or exponent. I said you we need to use the rule, if bases are equal, equate powers. This x power 3 whole power 1 by 4 and x power 5 whole power 1 by 12. I just wrote this root in terms of root rad in terms of exponent, and this turns to be x power 3 by 4 and x power 5 by 12. So you can see x and here also x. So apply the product rule, x power 3 by 4 plus 5 by 12, that equals to x power by n. So you see this is are getting equal, and now just doing this addition, you're going to get 12 3 is 36, 36 plus 20, 56 by 48. So you're going to get 56 by 48. That's going to be 8 times 6 and 8 times 7. So here you have x power by n. So you end up x power 7 by 6, that equals to x power by n. So this is what we need to find. Now we apply this. If bases are equal, we equate powers. So on equating powers directly, we are going to get 7 by 6 for value by n. I just equated powers. So this is what we get, 7 by 6. That's the value. Question number 16. Two numbers p and q are each greater than 0, and the square of p is equal to the cube root of q. And the square of p is equals to cube root of q. Cube root of q. For what value of x is p to the raised to the power of 1 by 6, p raised to the power of 1 by 1 minus x, is equals to square root of q. Square root of q, just normal root. So we just have to find the value of x. For what value of x this thing will be equal to this? So for what value? So what is the value of x? How can we get that? So here x value is in the exponent. Then we have to apply same thing. If bases are equal, then only we can able to get the value of powers, like bases are equal, equate powers. So how can we make bases same? For that, they given some other information here. In that information, you can get the value of q. You can get it easily. So what I do is, here cube root is there. I'm trying to get the value of q. Why? If I get the value of q, I'll get in terms of p. If I put that here, this complete term changes to base p. Now I can apply that thing what I said. Bases are equal, equate powers. Let me solve this. So p square here, cubing on both sides. So if I do cubing on both sides for the given expression, p square equals to cube root of q. And if I do whole cube, that's going to be this cube and this off. So p power 2 into 3 directly 6, that equals to q. So we got q value as p power 6. I'll just substitute p power 6 in the place of q. So p power 1 minus x. Now I try to match up this p and this p. So which means I need not have this root. So p power 1 minus x, that's going to be p power 6 by 2 directly, because root will be 1 by 2. So what do you have now? Bases same. If bases are equal, equate powers. So just equate those exponents, you'll get the value of x. 1 minus x equals to 6 by 2. So 1 minus x equals to 3. Two ones and two threes. So x value is equals to 1 minus 3 equals to x. X equals to negative 2. I repeat, we solved few questions at the end. Like most of them are, we are trying to find the value of something which is in exponent. If that is the case, you try to make the bases same and equate the powers. That is the only way you can get the solution. Exercise 5, question number 1. Which expression is equivalent to rad 100 x raised to the power of 36? We have few options. After watching options, we need to get an idea that answer will be 10, because 100, if you just split this root 100 and root x power 36, this root 100 value is 10. You need to be good at with some root values. Root 100 is 10 because it's going to be 10 square. Square root of it's going to be 10. That's how I just took the value of 10 here. And this is going to be x power 36 whole power 1 by 2. I just turn this root to 1 by 2, I mean to the exponent. So that's going to be x power 36 divided by 2, which is 18. 10 times x power 18, so which is option C. Question number 2. If 5 raised to the power of 3 whole raised to the power of 4k, 5 raised to the power of 1 by 3 whole raised to the power of 24, what is the value of k? You see, they're asking us to find the value of k, where k is in exponent. If the question asked to find something in exponent, the unknown value of something which is in exponent, you need to always remember one thing. If bases are equal, equate powers. So why I'm saying this, because this is the only way to solve and get the value of k which is unknown, which is in the exponent. Anytime if they ask you to find the unknown value in the exponent, try to make this basis value same. Here already bases are same, 5 and 5, and then equate their powers. So 5 power 3 whole power 4k, that equals 5 raised to the power of 1 by 3 whole power 24. So this is going to be, after applying power rule, 3 times 4, which is 12k. This is going to be 5 power 24 divided by 3. 3 times 1, 3 times 8. So it's going to be 5 power 8 directly. So now you can see clearly bases are equal, equate powers. So 12k equals 8, k equals to 8 by 12, 4 times 2, 4 times 3, k equals to 2 by 3, which is option B. Which of the following is equivalent to 3y raised to the power of 1 by 2 for all y greater than 0? So here 3y raised to the power of 1 by 2. You see the options and eliminate them. 3 is there. 3 is individual. Only for y 1 power 1 by 2 is there. So this is definitely incorrect, because for 3 there is no under root. I mean there is nothing to it. And here root 9 and y under root 9y. So this will match with our answer, because if you split this, it's going to be root 9 root y. That's going to be root 9 value is 3, and root y, which is equals to 3y raised to the power of 1 by 2. So option B. it's definitely not going to C, because it's going to be root 3 root y. This is going to be root 3, and if you bring this y to the numerator, it's going to be y raised to the power of negative 1 by 2, because this is y raised to the power of 1 by 2. When you bring it to the top, it's going to be negative 1 by 2, but definitely it's not matching with the same here root. If we solve this, root 9 by root y, so root 9 times divided by y power 1 by 2, that equals to root 9 is 3, and if you bring this to the numerator, y raised to the power of 1 by negative 1 by 2, so 3 y raised to the power of negative 1 by 2, no, it's not going to be true. So it's option B is correct. Which expression is equivalent to this? So 4 power plus 2. So we have few options. I'll just try to split and solve this. So it's going to be 4 power 2. So 4 power we can't do anything, but 4 square is 16. So 16 times 4 power, which is matching with option D. Which expression is equivalent to this, where x value is greater than 0 and y value greater than 0? So just have to solve it. The root of x square and y raised to the power of 4. So that's going to be x square y power 4 whole power 1 by 4. Now bring in that 1 by 4 inside. So it's going to be 2 by 4 and y raised to the power of 4 by 4. So it's going to be x power 1 by 2, y power 1. This 2 times 1, 2 times 2, 4 times 1, 4 times 1. So do we have any option like that? X raised to the power of 1 by 2 and y? This is not x square. X raised to the power of 1 by 2. This is not going to be that, because x power negative it will come when it comes to numerator. This is both of them y also in the root. So no. Y just normal y, doesn't have any radical. So here y normal y root x, which is matching with our thing. This can be turned into root. So it's going to be y root x, which is option B. So which expression is equivalent to p raised to the power of 1 by 3 times parenthesis cube the root of p whole square, where p is greater than 0? Fine. Okay, I'll just try to solve this p power 1 by 3, and things which is in parenthesis is going to be 1 by 3 whole square. So this is going to be p power 1 by 3 and p power 2 by 3. So now apply product rule. P x power n equals to x power plus n. So that's going to be p power 1 by 3 plus 2 by 3. So that's going to be p power 3 by 3, that equals to p, which is option D. Question 7. Which expression is equivalent to x raised to the power of 2a by b for all positive values of x, where a, b are positive integers? Fine. X raised to the power of 2a by b. So if you see options, it has bth root. So mostly yes. So we can cut off this. So we can write this bth root of x power 2a. So I just did that, and it's not definitely going to be a times x square, because a is in power, not in the base. So it's not going to be true. Option B is right, because it's exactly matching and it is x power 2a, and it's not definitely x raised to the power of a plus 2. It's 2a, not even D. Question 8. If 9 raised to the power of 7 divided by fourth root of 9 raised to the power of 10, that equals to 9 raised to the power of 60, what is the value of t? I repeat, we have to find the value of t, which is unknown and it is in the exponent. You have to use if bases are equal, equate powers. So you have to make this complete equals to the this term. Then you equate powers to get the value of t, which is unknown. So let's see, here you can see 9 9 same. So let's try to solve it. LHS 9 raised to the power of 7 whole divided by 9 power 10 whole power 1 by 4, that equals to 9 raised to the power of 60. 9 raised to the power of 7 whole divided by 9 raised to the power of 10 by 4, that equals to 9 raised to the power of 60. 9 raised to the power of 7, 9 raised to the power of 2, 2's, 2 5's, that's 5 by 2, that equals to 9 raised to the power of 60. So now apply quotient rule here. So 9 raised to the power of 7 minus 5 by 2, that equals to 9 power 60. So now solve this part, it's going to be 7 to 14 minus 5, 9 divided by 2, you get 9 raised to the power of 9 by 2, that equals to 9 raised to the power of 60. So you can see clearly now bases are equal, equate powers. 9 by 2 equals to 60. So forward this, that's going to be 9 by 6 to 12, that equals to t. 3's 3 fours, t value equals to 3 by 4. So that's how you need to find. Question 9. Which expression is equivalent to a raised to the power of 3 by 4, b raised to the power of 1 by 2, where a greater than or equals to 0 and b greater than or equals to 0? So we just have to see the options and go with it. Here it doesn't, it's just square root, and here fourth root, that is the difference. And here we have a raised to the power of 3 by 4, b raised to the power of 1 by 2, but here they doesn't have something like that. So here two options have with fourth root, root is 4, so we'll try to make this as a fourth root, and we'll try, and the other one is square root, we'll try to make the exponents too. So first let's go with option a and b. So just keep this part as it is, 3 by 4 and b power 1 by 2. So now I'll just multiply 2 in the numerator and denominator for the exponent of b. I mean, yes, I'm going to get a power 3 by 4 and b power 2 by 4. So that's going to be a power 3, b power 2, and whole power 1 by 4. I just took this 1 by 4 exponent in common in both and I wrote whole. So that's going to be fourth root of a power 3, b power 2, which is exactly matching with option b. This is one option. If this doesn't work, you have to try with c to make this 2, like you just have to do something, divide it by 2, something like that, and you can get it. What is the other way? You just have to check it. If you just get with this, you're going to get a raised to the power of 3 by 4 and b raised to the power of 1 by 4. If you just give this root, fourth root to them, turn it into exponent, you get this part, which is not matching with the given question, so obviously incorrect. And the second one, if you do a raised to the power of 3 by 4, you get, and b raised to the power of 2 by 4, you get. So 2 times 1, 2 times 2. So this is going to be a raised to the power of 3 by 4, b raised to the power of 1 by 2, which is matching with the option. If you check with this option c, a raised to the power of 3 by 2 and b only, because here root is not continued for it, so it's only b, which is not matching with the question. So option c also incorrect. So this one, if you try a power 4 by 2 and b power 2 by 2, that's going to be a power 2 ones, 2 twos, 2 ones, 2 ones. So that's a power 2, b power 1, which is again not matching with the given question. So definitely option d wrong, option b is correct. So whenever you don't have any idea, try solving all options. One among them will match with the option, match with the question, I mean. Which expression is equivalent to h raised to the power of 5 by 12, parenthesis, h raised to the power of 1 by 4 whole raised to the power of 7 by 3, where h greater than 0. So obviously we have to solve that, then only it gets reduced and match with one of the option. So that's going to be h raised to the power of 5 by 12. And the other one, here applying power rule, x raised to the power of times x power n. So just apply the power rule. So you are going to get negative 7 multiply 1 into 7 is 7, divided by 4 into 3, 12. So again, what you're going to apply now, here in this step, you're going to apply, bases are same, you have to apply power product rule, x power times x power n, x power plus n. So that's going to be h raised to the power of 5 by 12, negative 7 by 12. So that's going to be h raised to the power of negative 2 by 12. That is equals to 2 ones to 6, negative 1 by 6. So h raised to the power of negative 1 by 6, it equals to, it is definitely not a, it does, because h raised to the power of 1 by 6, it's not 6, it's in the denominator given 6, it's definitely not this, because it has a 5 as power is 5. And then here it can be, because 1 divided by h raised to the power of 1 by 6, if we turn it to the numerator, h raised to the power of negative 1 by 6. So this is option c, it's matching. So we can turn this one, it's negative, so when you turn it into positive, 1 h raised to the power of 1 by 6, and it turns 1 divided by 6, root of h, which is option C. And if you turn this, you're going to get something like 1 by h power 2 by 5, which is not going to match h raised to the power of negative 2 by 5. That is incorrect. Question number 11. Eighth root of 41k parenthesis ninth root of 41k whole raised to the power of 12. For what value of x is the given expression equivalent to equals to 41k raised to the power of 25x, where k value greater than 1? We have to find for what value of x this term and this term will be equal completely. So we need to find x equals to how much, and where is x? X is in the exponent. Whenever you're finding an unknown in the exponent, you have to apply when bases are equal equate powers. So you have to make this complete and this complete term and then equate powers. So what I'm going to do is, you see here 41k, 41k, here also 41k. So don't disturb that. Just write 41k whole raised to the power of 1 by 8. And again, 41k whole raised to the power of 1 by 9. I just turn this roots to exponents. Whole raised to the power of 12, that equals to 41k whole raised to the power of 25x. So 41k whole raised to the power of 1 by 8. This one turns to 41k. Apply power rule, it's going to be 12 by 9 you're going to get here. 12 times 1 is 12 by 9. 12 by 9, okay, I'll write 12 by 9, and then it's going to be 3 times 4, 3 times 3, that equals to 41k whole raised to the power of 25x. So same thing here, 41k, 41k, apply product rule. So 41k whole raised to the power of 1 by 8 plus 4 by 3, that equals 41k whole raised to the power of 25x. So just solve this part. It's going to be 3 and 20, 32. 41k whole raised to the power of 3 plus 32 by 24, that equals to 41k whole raised to the power of 25x. So 41k whole raised to the power of 35 by 24, that equals to 41k whole raised to the power of 25x. Now you can see clearly bases completely same on LHS and RHS. Now we are going to equate powers. So 35 divided by 24, that equals to 25x. So you need x, so just isolate x. So just transpose this 35 by, I mean transpose 25 to other side. It's going to be 1 by 25, that equals to x. So cross out thing, 5 times 7, 5 times 5. So that's going to be 7 times 1, which is 7. 24 times 5, it's going to be 120 equals to x. X value equals to 7 by 120. The same story I repeat again. Whenever the question is about finding unknown which is in the exponent, you have to make the bases same, equate powers. Question number 12. The expression 4 raised to the power of 18x is equivalent to k raised to the power of 3x. 4 raised to the power of 18x equals to k raised to the power of 3x, where k is a constant. What is the value of k? They're asking us to find the value of k. It is in the base only, it's not in power. So yeah. So what we do is, we make k isolate. We isolate k. So which means we are going to remove this part. How we are going to remove that part? 3x 3x rad on both sides. So that's going to be 3x rad. It's going to be 4 raised to the power of 18x. That's going to be 3x rad k whole raised to the power of 3x. So why I did this? Because I can able to cross out this 3x 3x. So I will isolate k. So now this 4 raised to the power of 18x divided by 3x. So I just converted this rad to exponent. So that's going to be k. So x out, 3 times 1, 3 times 6. So 4 raised to the power of 6 equals to k. So that's going to be, so 4 times 4 times 4 times 4 times 4 times 4 equals k. So 4 4 16, 16 4 64. 4 4 16, 16 4 64. So that equals to k. You can directly use calculator and also can be done 4 raised to the power of 6. So 64 times 64 you do 4096, that equals to k. This is what you're going to get. Which expression is equivalent to 9 raised to the power of 1 by n parenthesis 4 raised to the power of 1 by 2n, where n is a positive integer? So we have to solve it. That's the only way. So 9 raised to the power of 1 by n. What I'll do is I'll just turn this 4 as 2 square, whole raised to the power of 1 by 2n still there. So it's going to be 9 raised to the power of 1 by n, 2 raised to the power of 2 by 2n, applying power rule. So 2 out, it's going to be 9 raised to the power of 1 by n, 2 raised to the power of 1 by n. So 1 by n common, you can write 2, 9 times 2 whole raised to the power of 1 by n. So it's 18 raised to the power of 1 by n. So that's going to be option C, which is nth root of 18. So you need to get this idea. Like you need to understand that 1 by n is in the power. So how can I make this and this reduce so that I can get 1 by n? So that will help us to take something, these things put together, and we can convert it into solution. Question number 14. The given expression is equivalent to a x power b, where a greater than 0, b greater than 0, x greater than 1. What is the value of ab? Here you have to find the value of a times b. So you have to find the value which is in exponent at the same time as a coefficient. I mean a and b values. So here it's not only finding the exponent which is unknown, we have to find something else along with that. So don't completely go with the thing what I said, bases are equal, equate powers. No, just solve it. Moving ahead, it help you to reach solution. So first what I'll do is I'll try to solve this. I'll try to match with this part. It will help us to solve it. So 10, I'll just write 9 cube times x power 48 whole raised to the power of 1 by 6 divided by 6 raised to the power of 4 times x whole power 1 by 4. This is separate x, not the power x. So that equals to a x raised to the power of b. So now what happens in the numerator? 10 times 9 raised to the power of 3 by 6. Just apply power rule, x raised to the power of 48 by 6 divided by 6 power 4, x raised to the power of 4 by 4, x raised to the power of 1 by 4. That equals to a x raised to the power of b. So it's going to be 10, 9 raised to the power of 3 times 1, 3 times 2, 1 by 2, x raised to the power of 6 times 1, 6 times 8. So it's going to be 8, 4 times 1, 4 times 1 in the denominator. It's 6 power 1, x power 1 by 4. So what all we can do changes now in the numerator and denominator. Here this value we can turn it into 3 because it's going to be square root of 9, which is 3. So I'll just change that value to 3, and rest, this is going to be 10 and divided by 6, and this x power 8, x power 1 by 4 I just wrote separate because I'm going to apply quotient rule to it and try to reduce. That's going to be 3 times 1, 3 times 2, 2 times 1, 2 times 5. So it's 5 dot x raised to the power of 8 minus 1 by 4, that equals to a raised to the power of x power b. So now 5 x raised to the power 8 4 is 32 minus 1, 31 by 4, that equals to a raised to the power of ax raised to the power of b. So now you can see both are exactly matching, this and this, where a value equals to 5, b value equals to 31 divided by 4. But we need to find the value of a times b, not a and b. So a b, that equals to 5 multiplied by 31 by 4. So a b, that equals to 155 divided by 4. 38.75. Anything, you can write it in decimal or fraction. If and n are both positive numbers and 4m is equal to the cube root of the square of n, 4 is equal to the cube root of the square of n, equal to the cubed root of square of n for what value of x is power x equals to n, where n equals to 2, we have to find the value of x. So for what value of x, this power x is equals to n. So we have some information here to solve, which is this. We have to find the value of x. It is in exponent, which is unknown completely. So may we can do that. So before that, here there is n. If we can able to get the value of n, we can able to get the value of x. But how can we get the value of n? Here you see n is with this. If we just isolate n by this and this getting removed, we get the value in terms of, so we can write terms of here, which is n, and then by solving it we get the value of x by applying the bases are equal equate powers. So let's get the value of n. So here we have to remove first this cubed root. So to remove cubed root, cubing on both sides. So cubing on both sides, so it's going to be 4m whole power 3, that equals to cubed root of n square whole power 3. So this and this out, if you apply cubed root inside, so 4 16 16 4 64 and power 3, that equals to n square. Now we have to remove this square. To remove square root on both sides, so it's going to be square root of 64 m cube, that equals to n square square root. So this square root and square gets cancelled off. So square root of 64 and square root of cube, that equals to n. I just made simple, so it's going to be 8. This value is going to be power 3 by 2, that equals to n. So now you have n completely in terms of n. So just substitute that value in n. So here power x as it is, n what we got, n that equals to 8 times power 3 by 2. Here it is not n equals to 2, it's equals to 2. So I'll just substitute 2 in place of m, that equals to 8, 2 power 3 by 2, and here x. So 2 power x, that equals to, here 8 is there, 2 is there. We have to write in such a way that bases must be equal. So what I'll do is, this 8 I'll turn it as 2 power 3, and this will be 2 power 3 by 2 as it is. So that's going to be 2 power x, that equals to 2 power 3 plus 3 by 2. So 2 power x, that equals to 2 power 2 3 6 plus 3 9 by 2. Now bases are equal equate powers, so that x equals to 9 by 2 directly. That's how you can able to find. So ultimately, to find something which is in exponent and unknown, you have to apply bases are equal equate powers. So what I did first, with the help of given information, I got the value of in terms of, so that n value I just substituted in the place of n, and then I made this bases equal, and I got the value of x. Question 16. If 2 raised to the power of x plus 3 minus 2 raised to the power of x, that equals to k times 2 raised to the power of x. So this is going to be 2 power x and 2 power 3. I just split it because I saw 2 power n, I mean sorry, 2 power x, 2 power x in here also and here also. So that we can take as common and progress. So I'll just take 2 power x common. Now it's going to be 2 power 3 minus 1, that equals to k 2 power x. So just cross out this 2 power x on both sides. So you end up with 2 power 3 is 8 minus 1, which is equals to k. So we have to find the value of k. K equals to 7. Done. Complete chapter is done.